Hello friends, welcome back to the bench. Today we have this Surface Pro 4 with very unusual charging issues. Normally with charging issues on laptops, it's either it charges or it doesn't charge. Perhaps you can boot it from the battery, but there's no charging. And perhaps like we had in case of the Chromebook, the laptop would detect the battery, but it would not charge. And in that case, we had a shorted MOSFET, one of two MOSFETs on the input. Now in this one, I know this is not the case because it charges to about half the battery. It will charge pretty much 50% of the battery, roughly, and it will stop charging. It just consumes enough power to power up the computer, but not enough. It's not consuming enough to recharge the battery. Now, pretty much every laptop, modern laptop, by modern I mean in the last 10 years maybe, is gonna the heart of the charging circuitry will be the BQ chip. Which is great because BQ chip is well documented, and we also have a schematic and board view for this particular board. So first let's analyze what could be causing such behavior before we actually open the laptop. So here we have a Surface Pro, exact same model, only disassembled. All the shields are taken off, so we can analyze the board, and we can measure voltages. Right now, let's see the typical application of our BQ chip. Right, this is our BQ 24770, and let's go quickly analyze how it works. It's actually relatively simple from the perspective of a repair technician. It's very simple. If I had to design such a circuit, it wouldn't be as simple for me. But from the repair perspective, it's relatively simple. We have our adapter, right? So that's our voltage. Typically, the resistor divider is going to be through resistor divider. We're going to connect to AC detection, and that is the pin that detects whether the adapter is on, whether the adapter is connected to the device. In our last case, this transistor Q2 was shorted. That's why the laptop wouldn't charge, but it would detect the charger, right? Because usually nothing happens to this resistor divider. And our two transistors, Q1 and Q2, are the ones that open when the adapter is connected, so we can allow the battery to start charging. It's actually, and this is not the only requirement for the battery to start charging, but that's our phase one. Then we have, in this case, 10 milliohm resistor that is basically a current sensing resistor. Those two diodes, two Zener diodes, as you can see, one is connected to the battery, the other to the adapter, is just to supply VCC to the chip so the chip can work. Nothing special here. Going further, the voltage that we enabled by opening these two MOSFETs will be provided to two transistors, which will be driving the coil. This coil is what actually supplies the battery. Past the coil, we have another current sensing resistor, 10 milliohm at least on this schematic, and one last transistor MOSFET, in this case P channel, that will allow the battery to charge, right? So if the battery is not charging, first thing we need to check whether this transistor is opening. If this transistor is shorted, the charging will not happen either, right? If you replace it with the wire, it will not be charging. Then in this case, on this schematic, we have 2 transistors, but on our surface, this is a single chip with 2 transistors in it. And these 2 transistors, right? That's normally what I check on these charging circuits. And usually when there's a problem, it's one of those 3 transistors. This one less often. Most often, it's either this one or this one. And this is actually easy to reproduce. I accidentally found a nice way of destroying this circuit. When you start charging it and you create a short, so you basically short the drain of Q1 to ground, this transistor will go short. So that's kind of interesting. But basically, this is usually what I fix on these. But I know that's not the case here, because if any of these 3 transistors was shorted, there would be no charging whatsoever. Battery would not charge. The laptop would still work, powered from the battery, but it would not charge. This one is charging. So let's take a look at our actual schematic, right? We have PQ6301, that's our first transistor, 6302, our second transistor, right? And on the board, okay, we crashed. So these are our 2 transistors, 6301 and 6302, right? So this is going to be our drain, and this is our external DC in, right? Then source goes to the drain of the second MOSFET, and we have a feedback, right? And this is our big resistor, which on the schematic is here. This is 15 milliamps as opposed to 10 as described by the typical application. So this is where we detecting how much current are we drawing from the DC in. We're gonna have roughly 12 volts over here and roughly 15 volts over here. And then we have our oh, by the way, this is our BQ chip, 6301. But that's not relevant. We know the BQ chip is working because we're charging, and we're just not charging fully. So the BQ chip, probably there's nothing wrong with it, and very rarely the BQ chip actually goes bad. At least in my experience. Obviously, it does go bad from time to time. So this is our transistor gate, our transistor array, right here, PQ6304. And from there, we supply our output, are these 3 pins. We supply coil. This is 2.7 microhenries, 8 amps, very powerful, very big coil. And our second current sensing resistor over here, which supplies voltage to our one last switch, which is Q6301. This one. Right, and once this one opens, we have roughly 8 volts over here on this resistor, and through these 4 coils we go directly to the battery connector, which is on the other side right here. This is our positive, this is our negative, and our SM data and our SM clock. So these 2 pins are used for communication. This one for battery detection. This one IRQ, I have no idea what that is, but I assume this is to turn on the battery or something like that. Maybe this one goes to ground, and that's when the battery turns on, starts delivering power. This is maybe. I'm not sure. Maybe the data needs to actually be provided to the battery to turn it on. I have no idea, and I just kind of treat the battery as its own circuitry. I don't have schematics for the board that is on the battery, so or board view. So I don't know how it works, and it's not really relevant because I'm just going to replace the battery if I suspect the battery is faulty. So basically, this is how it works. Now let's take a look at the board and see it on the actual board. So these are our two input transistors, right? So we have 15 volts here, and this is our resistor, the first current sensing resistor, our BQ chip, our transistor gate over here, our transistor array, big coil, second current sensing resistor, and one last transistor that opens the voltage for the battery. So here on this resistor or on the source of this transistor, we're gonna have roughly 8 volts going to the battery. Our input over here, that's gonna be our charger voltage, so it's gonna be roughly 15 volts. Now I have this this computer. This battery is charged, and this battery had a problem, as you can see over here. The connector was ripped, right? But only this connection was damaged. So for now, I just soldered it in over here. We're gonna fix it later, but it's just my testing rig anyways, so I'm not too worried about that. Now, let's connect it. So what I'm gonna use is the converter to USB-C and then USB-C power meter, right? That's one way of doing it. The other would be to just connect 15 volts to this and run it through a power, the bench power supply. But I just chose it to do it this way. And now let's, I said it, why was it consuming some? It's consuming 400 milliwatts. That's weird. Anyways, let's connect it. And we are drawing 12 watts. That means the battery is charged. And I know it's charged because I charged it. Not fully, but it's almost fully charged. And normally it would go to 22 watts. That's the maximum charging current or charging power. When the laptop is on and discharged, you're gonna go as far as about 36 watts. I just noticed a little burn over here. Oh, that's weird, I haven't noticed that before, but let's just hook up some power. We have 8 on the coil, we have 8.7 volts, right? On the current sensing resistor, 8.69. Of the sensing resistor, 8.67. So we can calculate how much power is going through it. And now, if this transistor opens, we're gonna have 8.67 over here. Our 4 coils. So on the coils, the output, we have 8.6 volts. So the battery is charging right now, right? From here we go directly to the battery. Now let's take a look at this burn mark over here, just to satisfy our curiosity. Oh yeah. So this is probably my fault. I probably did that by connecting the battery or disconnecting the battery while it was working. So too much current went there. Let's see. Is it getting hot? It is not getting hot. It probably, this coil is ruined, but all these 4 coils are connected in parallel, so that's fine. I mean, it's not fine. It should be replaced. But this is my working working donor, right? If I need any parts, I will retrieve them from here. Now let's connect the laptop that doesn't work or doesn't charge. And now you can see it's drawing 22 watts. That means the battery is, well, less than 50% charged, right? It's charging with full current. But this will this will be charging for about well, some time. I don't remember how long, but maybe 20 minutes, 15-20 minutes. It'll go to roughly 50% of the battery, and it'll stop charging. It still detects the charger. The computer will turn on. The computer will work just fine. It's capable of discharging the battery. So if I disconnect the charger, the computer still works, but it will not charge over roughly 50%. And that's what makes it so interesting, this particular case, because we're not looking for shorted MOSFETs, we're not looking for open resistors. I wouldn't expect the coil to be damaged. My suspicion is that it's the battery. The battery is just old, and as it recharges, it either produces too much heat, and that is detected after some recharging time, or the cells just start taking too much current, and that's what causes the charging circuit to shut off. As you can see, it's still charging. The laptop also has a problem with a digitizer. It kind of works intermittently. Sometimes it stops working. Sometimes only a part, like this corner, left bottom corner where you have start menu. That one sometimes doesn't work. You can tap here but not here, but then it goes away. Either way, there's something wrong with the digitizer, and that's actually unsurprising because there are some blemishes on the screen, so probably it has been either dropped or suffered liquid damage. That would probably explain charging issues, because liquid damage can manifest in many different ways, and this would be one of them. But if there was a liquid damage, we will see the evidence of it, and then perhaps we can just replace some components and charging will return. So let's open it, and this time let's open it without damaging the screen, because this one is not cracked, right? It doesn't quite work as it's supposed to, but it's not cracked, which means I don't have an excuse not to take it off without damaging it. And by damaging, I mean it should still display, right? Display should still be working fully, and that is possible because the only damage you are bound to make is some scratches here and there, but that's it. It should work. And last time I mentioned that from the bottom over here you can work comfortably because there's not much stuff on that side, and that is true. There is not much stuff in the case in the laptop. However, this is where our cables go, right? So if you push too hard, especially with this tool, it will cut those wires. And that's exactly what I did over here. Right, I cut the wires when I was prying it open. That's why this particular screen displays just, I don't know, like few lines, right? So let's try to do it without any damage, which means I'm gonna terminate the video here and I'm gonna prep it. So first I'm gonna warm it up. I will use a hair dryer. I find that hair dryers really get the best job done as far as heating it up, because you need to heat up the entire laptop, but not too hot. Hair dryer is not going to heat it up too hot. The hotter gun doesn't have the, once I take out the nozzle, the heat gun doesn't have enough power, enough air to just heat up the whole thing uniformly. So once the laptop is warm, then I work with the heat gun and just heat it up where I'm actually prying it open. So that's what we shall do. And let's open it and do some measurements. In this case, as I connected it, we should see the regular 8 volts on the battery and the laptop will be charging properly. But we will wait until it stops charging and we'll see what is cutting off. This will likely be that last transistor that opens the battery. That is my guess, but we'll see if that is the case. I know what you're thinking. This should be easy because I should just swap the battery, right? And we'll know if the battery was the issue. And in this case, I do believe it will be the battery. But it's actually not that easy. It's actually it's a lot easier for me to replace any one of these components rather than replace the battery. To replace the battery, as you can see, battery connects from the back. To take out the battery, I need to remove the entire board. To remove the entire board, I need to remove a few of the shields to get the screws out. I need to remove this whole panel over here that holds the camera and stuff. Detach all the cables and everything, obviously. Then take out the board. The battery connector is glued in to the chassis. So I need to heat it up, take it off, and sometimes this happens, meaning the flex cable will just rip. I mean, if you're not careful, there's really no reason you should rip this cable. I have no idea how I did it, but that shouldn't happen. Normally, that will never happen. Just be gentle with it. Don't tear it, don't pull it. But basically, that's how you replace the battery. So battery replacement is awful on these devices. I do appreciate that the components used are pretty much off-the-shelf components, that the BIOS is available, that I have board views, that I have schematics. It's great. But this move of placing the battery first and then placing everything is like completely opposite. The battery should be the last thing that goes into laptop, because it's going to be the first thing you're going to have to replace, because batteries die. Batteries just use up. Alrighty, let's start heating the laptop and let's open it up without damaging the screen. Let's see if we can. Alright, so we have the board accessible. Unfortunately, I was not successful in getting the screen out without any damage. And this is actually significant damage. I'm not sure if the screen was damaged and I just didn't see it, because it was really hot and very flexible. And I was not rushing, so I'm surprised it did crack. So maybe there was damage. And well, we do know that the damage has been done to the screen because digitizer is not working properly, and we have blemishes so we can see where it was hit. So perhaps there were some microscopic damage that I couldn't see, and that's why it started cracking, or I just messed it up. In either case, the screen is going to be replaced on this one anyways, so I'm not too worried. I just wanted to retrieve this screen for later use because it works relatively well. It can still be used because I did not damage the connector. Yep, everything looks good here. So the screen should be working just fine. It's just I'm gonna have to place some tape on it just so I don't cut myself. Now let's connect our guy. We are drawing 22 watts, so we are charging perfectly. Now the battery is hot from me heating it. Now let's measure. What do we have here? We have 7.9 on the coil. Okay, that is curious because it's the voltage is a little lower. We have 15 volts here and so the highest temperature should be on the coil and on the, no, actually not on the coil, on our transistor gate, our transistor array. And indeed, we have 46. It's kind of stable at 46 degrees. It's not overheating. Alright, so it's not our charging circuit. So what I would expect here, if this was a charging circuit issue, I would expect that transistor in array, this chip, I would expect it to get hot, or I would expect this chip to get hot. Both of these will have thermal shutdown, right? So it would make sense if this one heats up, then we're shutting down. Coil, well, there's no thermal feedback on the coil, but if the coil gets too hot, the BQ chip should be able to detect that via the current sensing resistors. Now this little resistor that looks like current sensing resistor, it is not actually. It is connected to ground, and via this capacitor, this tiny capacitor, get something better to put maybe. This capacitor is connected to the coil and through this resistor to the ground. And let's see if we can see that on this circuit right here. So that's our cap and our big resistor going to the ground. So this is just grounding our coil via capacitor. So if that was getting hot, that would also tell us something, but it is not. So nothing is heating up, or at least not above normal. Obviously it's slightly warm, or at least using my finger I feel over here, but using thermal camera, the most heat comes from this guy. These are our transistors. So that is expected. This chip is going to be heating up because it needs to pump a lot of current through it. So yeah, I don't see anything wrong over here. So in case of this laptop, we're still charging with 21 watts. But in case of this laptop, the battery is at fault. That's the only thing that can cause this. And I will know once I replace it, but I'm not going to bore you guys with it because it's pretty straightforward. However, it takes plenty of time. All of these screws need to come off, all of the shields, pretty much all of them, maybe not completely all of them, but pretty much. Our SSD needs to be removed, and it's also shielded. These shields are kind of pain to take off, especially without damage to the shields. The little ones, like these, I did some damage over here, but this one's completely reusable, not damaged, right? These ones, a little bending here and there, but they can be reused. This one, on the other hand, this one will be tough to reuse because I need to straighten it. And with these big ones, yeah, like no, that's not damaged. This is supposed to look like this. But this one still can be reused. Some cannot. Luckily, I have some spare ones. I would love to have a tool like a magnetic tool, so I can clip onto that shield and just pull it off. But as far as I know, the tool like that doesn't exist. I would have to create one, build one. I might do that, but for now, it's just tedious process removing these. Even removing the display is a lot easier than removing the board. It's just a lot of screws and you need to keep track of them. There are different sizes, and luckily the same head, the same bit for all of the screws, but different sizes of the screws. They need to go back to the places they came from. And that's not straightforward procedure because there's a lot of them. And yeah, other than that, it's not that hard. There's not much you can break doing that. I mean, you could like over here, right underneath this, we have another connector which is basically just bent copper plate, and once you bend those pins, it's tough to get the good connection anymore. Not to mention that you can make a short, that connector can connect to what it's not supposed to connect to, and that's a big problem. So overall repairability of this is pretty low, despite having schematic, having board view. Despite that, repairability is very low and it's very hard to repair because the majority of the repairs on these is gonna be the battery, like in this case. Because, well, the battery just gets old, and this is Surface Pro 4, quite a few years since it came out. This is the original battery, so obviously this is the first thing that will have to be replaced. And just to replace the battery, you need to remove all this. It's a pain, and this is something that I really don't like about these. But all things considered, like as you can see, I don't repair switches. Why do I not repair switches? Because there is no schematics, no board views, right? As far as I know, as far as I asked everywhere, Nobody has them. I've never seen anyone using schematics or board view for switches anywhere on YouTube. So if someone has it, they're staying low. But I can say that I blame them, because Sony seems to be really on top of that, on their intellectual property, even more so than Apple and any other companies. So for almost all the other devices, or maybe let me put it this way, I usually don't repair stuff if I can find at least board view, because schematics are sometimes tricky. Very rarely you have schematic but not board view, which is worse than having board view and no schematic. Schematic obviously will tell you a lot, but then to identify those components on the board, it can be very tricky. You really need to be experienced in doing that, perhaps experience in building the drawing the boards, developing the board views. That probably would be beneficial. I'm not, so it's very hard for me to go from schematic to identifying everything on the board. That's why even if I don't have the schematic and I see BQ chip, right, I don't need the schematic, because it's going to look pretty much like the typical application. But as long as I have board view, I can identify everything, and it's a lot easier for me. But it's always the best if you have both schematic and board view. That's why, to me, these machines are very much repairable, because I have those. And the same with some other stuff that I repair. As long as I have schematics, I feel comfortable repairing it. Without the schematics, it takes a lot of brain power to repair stuff. Except the charging circuitry, because this is pretty much the same on every board. As long as it's powered by BQ chip, you're gonna quickly identify all the other components. But as I said, it's much better if you have board view. That makes the job much more comfortable, you are much more effective when you have board views and schematics. All right, fellas. I will probably update the comment on the video whether the battery replacement solved the problem. But in this case, that is the only possible reason for the laptop to stop charging after a while, because nothing else is wrong on the board. And as you can see, it has been has it been 19 minutes? No. Well, the timer says 19. Oh, right, because it was 19 minutes since I connected, right? So it hasn't been 19 minutes since it's been charging, but for quite a few minutes now, it's been charging with 22 watts, and it will recharge the battery to about half, to about 50%, and then it will stop charging. So I might let you know, but this is pretty much this is pretty much confirmed that this is faulty battery. So that's what will fix this. All right, fellas. Hope you found this useful, because this kind of circuitry is going to be pretty much on every laptop, or on the majority of laptops that are, well, majority of laptops. I'm not sure about Macs. Obviously, they're going to have probably some specific chips that they manufacture, or they order at the manufacturer, and not allowing anyone to order them, so you can't replace them. But all the normal normal laptops that are not super anti-repair will have this circuitry, because it's simple, it's reliable, it's tested. Thank you guys very much for watching, and I shall see you in the next one.